In this section, we will discuss what you need to know about the way Azima approaches a vibration analysis program. This section will not get into how to create these machines in Alert, but rather what you should understand about the machines when it is set up, and how this affects you when collecting data in the field. This section begins on page 5 of the associated workbook. When we approach setting up a vibration analysis program on plant machinery, there are certain things about the operation of the machine candidates to make sure they conform to Azima's methodology. Azima does not approach vibration analysis as a troubleshooting program, though the TRIO and software can certainly be used to perform simple and advanced troubleshooting. Azima programs are trending programs, taking high-quality data in very established, consistent, and repeatable test operating conditions to use software animation and expert intelligence to make rapid diagnostic evaluations. To support this, we must answer a few questions about the machinery. First, is it a good candidate? Let's say you have a desk fan you bought at Walmart or Target. It has a motor, it has bearings, it produces vibration, and you can definitely analyze it to know if it's healthy or failing. But if the ultimate decision will be to just let it fail, it's not a good candidate for a program. If when it fails, it takes down all of our production, well, that's a different story. Next, we should understand the components that make up the machine. Azima analyzes the machine train in its entirety. We consider a machine the sum of all of its components. When the data collected is ran by the expert system and reviewed by an analyst, it considers how vibration is presented across the entire machine and how it impacts or travels through each of the components. When collecting, it is important to gather all of the machine test locations on a machine as quickly as possible. We must ensure the conditions of the machine are consistent from the first test to the last. The TRIO software does not care the order collected, just as long as all the locations are collected in a short amount of time. During the collection, the machine should not only be in a stable condition, but must be at the condition that is defined by the test operating conditions. These are presented on the TRIO during collection. Azima uses a comparison to healthy machines to find any subtle changes that may indicate a fault, called a fault feature extraction. To perform this, the machine must be operating the same way each time, be it always on fast speed or at a specific VFD setting or a discharge output. The specific conditions isn't important, but the consistency of always collecting in the same way is. These conditions must be repeatable. If you find that you cannot easily meet the operating conditions required, please contact your analyst. Finally, the locations where data will be collected should have some sort of installed attachment pad. This ensures that whoever is collecting data will be consistent. Take a look at these three machines. If you notice, the machine in the back is different than the two in the front. Though the three all feed a common header, basically the same, Azima approaches these as two different machine groups. You will see the term MID, or Machine Internal Design, and VTAG, or Vibration Test and Analysis Guide, to describe these groups. These will be discussed in a later section. In essence, Azima programs use known healthy machine information to identify early faults. So in the example, there would be two different machine groups, one that represents the two in the front and one that represents the one in the back. Knowing the nameplate information could allow the knowledge from these machines to be applied to other similar machines in the plant or at another plant elsewhere. You should know your machines best, so if these three machines are what's expected, but one day that last machine, let's say, is replaced with a different model, stop and let your analyst know. So as we head to this pump room to collect data, we should find the machines running in a steady state condition. If normally only one machine is running, but today all three are running, well, that condition's not the same as what is considered normal, so don't collect data. If while collecting data the pump surges or cycles, again, this isn't normal condition and you should not collect the data. If there are variations to the conditions, like a VFD or an adjustable output, then review the test operating conditions in the collector application before collecting the data. Make sure you set those before you collect the data. When we collect data, you should be attaching your sensor to an attachment pad. We will next cover how those pads are configured. There may be only one pad on each component of the machine, or there may be an attachment pad on each bearing of the machine. This is determined by the analyst setting up the program. Last thing here is notice that stain on the floor, maybe from a leak, I don't know, who knows. But these types of situations are very important to the analyst looking at the data. If the machine is behaving abnormally, maybe it's hot to the touch, it sounds horrible, has some leak, add these notes along with the collected data. I will show you how to do that in a later section. Here's another pump room example. So let's review what we covered. In this room, we have two different machine groups. The three machines on the left seem to be all identical and would be one group. And the four machines on the right all seem to be identical and would be in its own group. We would confirm this by looking at the nameplates of each. If there is something different, like different manufacturer, different model, or frame size, the internals of the machine could be different. Let your analysts know so they can review and make any applicable changes. We know each side feeds its own common header, so if the configuration of number of machines running is different from normal, then this would impact the data. We see the motors have a bell housing covering a cooling fan. We cannot collect data on these housings. We would review any test operating conditions and configure these machines into those repeatable, consistent lineups before collecting data. While collecting data, we can take notes of anything abnormal and report this with the data being collected. Finally, if something has changed, like a motor has been replaced or maybe a pump has been overhauled, take note and send this information to your analyst to ensure the setups are as expected. In the next section, we will prepare these machines for data collection.